In this lesson, we're going to learn how to do a linear regression using a tool called Desmos. So what a linear regression is it's a way to get what's called the line of best fit through a particular scatter plot. So in order to do this, we need a scatter plot. And in order to enter our data, we're going to use this table that you see right up here in this corner. And whatever data you have, you simply type in the x values. So for my x values, I have 0 through 4, and for my y values I have 2, 3, 5, 4, and 6. And so you can see this creates a scatter plot. This has a positive correlation, so we are expecting some line that has a positive value. Now, I've set this up for you, and you can get this file off of Canvas so that you don't have to do any additional work. The linear regression will happen automatically, and this is what you see in this section right down here. I'll turn that on, and you can see it draws a line right through my data, and in fact this is the line of best fit. So we've created now a line that models this data, and we can see various information about this line given over here. If this line has an equation of, or in slope-intercept form, y equals mx plus b, this section right here will tell us what the slope is. The slope is 0.9. That makes sense. It's positive. We're expecting something with a positive slope. And we see that b, the y-intercept, is 2.2. So I can now write the equation for this line. That equation would be y equals 0.9 x plus 2.2, and now I have a line that models this data. I can use that line to make predictions for x and y. If I want to know what the y value is and I know an x, I just substitute it into that equation and I can find the corresponding y value, allowing me to make predictions. I can also just use the line itself. For instance, I can predict that if x equals 5, y should be somewhere in the neighborhood of 7. Now we can't say exactly, but we can make a good prediction that at around 5 it should be 7. Same thing for other values. I can say at 8 the value should be a little more than 9. So this allows us to make predictions using our scatter plot. This process is called linear regression. It gives me the equation of the line of best fit, the line that passes through our data, reducing the distance of each point from the line. And then we have this right here, r and r squared, which are called, or r we're going to call the correlation coefficient. What the correlation coefficient tells you is how well this line fits this data. And the closer this number is to 1, the better fit a line is for the data. So anything over about 0.7 is going to be reliable for our purposes. If you have something that's below 0.7, that line is not a tremendously good fit. And the closer this thing is to 1, the better your predictions are going to be using this line. So here we can see we have a correlation coefficient of 0.9. That tells us that this equation, this line, is a pretty good estimate of what's going on with this scatter plot. If it was a perfect 1, that means all of the dots would line up exactly on the line. But we can see there's a little bit off, so it's 0.9. R squared will become important when we start doing regression with what are called quadratics. For right now, we can just focus on R. You can also kind of get a visual interpretation of R. The closer R is to 1, the more of a line these points in the scatter plot are going to make. So if you see the points are kind of spread out in like a big cloud looking structure, that's going to tell you your R value is going to be smaller, and the more tightly grouped together, the closer your R value will be to 1. So again, this whole process is called linear regression. You simply put in your data into this Desmos tool that I've given you, and it will automatically pop up with the equation, which you can write from there, and the R value, which tells you how good of a fit your equation is to this data.